So I'd like to start you off with a question. Who here knows the acronym PEBCAK and what it means? This is a better result than I usually get. For those of you who do not know this acronym, it stands for problem that exists between chair and keyboard. The K and C are often reversed, making it keyboard and chair. Meaning is the same. It is obviously your desk. Or rather, you, I guess. Now before I start, I'd like to turn on my remote. I'd like to extend some special thanks to a community that I'm fairly active in, O10 PHP. This might be risky mentioning this here, but they're based in Rotterdam. Please don't lynch me, I'm not actually from there. They've given me the inspiration to enter the call for papers. They've convinced me that the worst DPC could say was yes. They said yes, so I guess the worst happened. They read my abstract, they helped me improve it, they gave me some feedback, allowed me to do a practice run. Great help, great bunch of people. If you're ever in the neighborhood and you don't mind going to Rotterdam, join us for a meetup. We're a good bunch of people. We're not all from Rotterdam, I swear. So a little about me, because that's apparently mandatory in talks. I didn't include a photo. I'm right here. I'm assuming most of you can see me. Those of you who can't see me won't have much use for a photo anyway. I'm a backend developer. I do mostly Symfony, especially the past few years. I don't exclusively do PHP. I do some Python. I want to get into Go. I've started with C and C++. Don't ask me why. If anybody's looking to get into programming, please advise them against that path. Not good. I'm a freelancer. It says hire me. Please do, but I'm booked until the end of the year, so you're going to have to wait a bit, I'm afraid, which is good for me. Maybe not so good for you. I don't know. I'm a security enthusiast. I've basically got an interest in cybersecurity as a little kid when I was thinking, yeah, cool, hackers. Reality's a bit different, but still interesting. I rant on Twitter. This is my Twitter handle up here. If you like random rants about anything and everything, give me a follow. I post pictures of food on Instagram. That's not an exaggeration or a euphemism or anything. There are exclusively pictures of food on Instagram, on my Instagram anyway. And I'm in a few communities, most notably PHPNL, which is the Dutch PHP Slack. I think many of you are already on there. Those of you who are not, you can join. And I'm on NetSec Focus, which is on netsecfocus.com. There are instructions on how to join. It's a Mattermost server, not actually Slack. Got a bit too expensive with a member count. 7,500 people on Slack on a paid membership. Costs a lot of money. They're a weird bunch of people, as one might expect from cybersecurity professionals and enthusiasts alike. But they're generally good people and surprisingly knowledgeable, considering the dumb random shit that gets thrown around every now and again. So let's start off the talk proper by looking at a technical problem. I don't expect all of you to know what this photo is, given that it's a cloud of smoke. This is a photo of the Challenger launch. The Challenger was a space shuttle, a rocket launch essentially, and for those of you who are not too familiar with aerospace engineering, this is not what a rocket launch is supposed to look like. This is bad. People died here. Something catastrophically failed. Essentially, the O-rings connecting the booster rockets to the main fuel tank, they leaked. And gases, when they expand, get really, really hot during a rocket launch, and they tend to melt things. When things melt on a flying rocket, right as the most stress during the launch is placed on all of the components, you get this. So what really happened? Because O-rings don't magically start leaking hot gas. That's just, unless it's been curry night maybe, but what happened was essentially they were too cold. It's weird. For something that goes into space, space is empty and generally seen as really, really, really cold. So for something to go into space to be too cold is weird. But it's interesting to look at how that happened. See, there is, when a rocket is launched, before a rocket is launched actually, they tend to design it. They build it, they test it over and over and over again. And you get this margin where the engineers are satisfied, this will be safe. Now it turns out that during the testing the O-rings already leaked. But, you know, they leak, hot gas blows past them, the O-ring kind of shifts in place and it self-seals. Now this is something that consistently happened during every testing run. They couldn't quite figure out how to stop it from leaking, but it self-sealed, so that gets documented. You know, O-rings leak, they self-seal, no worries. So you test some more, and you test some more, and you figure out that you have a safe range of temperatures in which to launch, like say 15 to 25 degrees centigrade. That is. For Fahrenheit that would be really low. I have no idea what that is in Fahrenheit, by the way. But, you know, the weather isn't always predictable. So during testing you think, you know, we might see what happens when you go outside these ranges and you launch at 14 degrees. Nothing bad happens. So you document like, well, the documented safe range is 15 to 25, but you know, you can launch at 14 if you really have to. And over the course of testing, at one point you hit 13 degrees. And still nothing bad happens, so you document that. Like if you really have to, you can launch at 13 degrees. Same thing with 12 degrees. Nothing really bad happens, so you document that we can launch at 12 degrees. So you get a launch window. You've planned everything. You think, well, everything's in the right place now, because apparently when you launch something into outer space and you need to go somewhere, things kind of need to line up, because otherwise the distances get really big. So you've planned that, but there are crosswinds, there are storms, there are everything. You can't really launch a rocket in those conditions, so you have to push the launch back. That's bad because it's a multi-billion-dollar project, and delays on that cost a lot of money to a lot of people. But you find a new launch window, but it's too hot out, and things might go wrong. You haven't really tested for that, so you'd rather not risk it. This happens a number of times. Bad weather conditions, wrong temperatures, you name it. Just an awful lot of bad luck all around. And then you find what seems to be the perfect launch window. But during the day it turns out it's about 12 degrees out, which is at the bottom of the range of what you tested. You can still launch at. But there was also a frost the night before. And that's something you didn't test. There's ice on the launch pad and you're all worried that it might blow up and damage the rocket, which is bad. But during the course of the day it gets slightly warmer, the ice starts to melt, and eventually the melted ice starts to dry up, and in the end people look at it and they say, well, we trust this launch pad. We can launch. And you launch, and it turns out that those O-rings that were self-sealing in all your tests tend not to be so self-sealing when they're still cold and brittle from the frost the night before. So they leak and the hole gets bigger and everything melts and a lot of people die. But wait a minute. I said this was a technical problem, but this wasn't so technical at all. There were people involved everywhere. Wrong decisions were made. The people went outside limits of testing, outside safe ranges. There were untested circumstances during the actual launch. This is 100% a people problem. And as it turns out, pure engineering problems, they're kind of rare. They don't really happen all that often. Every time we say we have a technical problem, somebody made a decision to do something. The purely technical problems we face are, for instance, the speed of light. Nobody really decided on that. It's just reality. We also can't really work around that. We only call it a problem because we like to think there's a solution to something. There's the halting problem, which is more of a theoretical or mathematical problem in software engineering on whether or not you can write a piece of software that determines whether another piece of software will eventually stop. Depending on your viewpoint, the answer is either no, you cannot because this introduces paradoxes, or yes, you can because everything will end sometime. But again, we only really call that a problem because we like to think about these things. We like to think there's a solution. They don't really get in the way of a whole lot of actual engineering. So while they are technical problems, they're not necessarily engineering problems. The engineering problems we face usually have people involved in some point of the process. Like, for instance, our users. I think you all know why I chose this photo for our users. I've spoken to a few of you who have done help desk jobs. You've seen the worst of it, I'm sure. There are designers, you know, the people who think that adding more color, more animations, basically tossing more design at things makes things better. So you get this fancy website with everything floating into view and blinking and moving, and everybody with ADHD finds your site completely unusable. There are managers who like to think they know everything about what you do, turn out not to know anything about what you do, but then demand that you do a week's worth of work in the next 2 hours. There's marketing with all kinds of super realistic claims, like your unhackable military-grade smartphone with blockchain encryption. Yeah, I get an itch just saying that. There's sales, only really caring about one thing, and that is getting as many people as possible to give them as much money as possible. Now, they have to give some of that to the business, but usually they work on some form of commission, so they're really, really interested in making that happen. And then you get things like these. Now, this is a big screen, so it might actually be readable. It's not always been readable in the past, but I'll explain what it is. The magical IoT sneakers you cannot wear because there is a software update for your sneakers. Let that sink in. The magical IoT thermostat, which has a server update in the middle of a blizzard, meaning you cannot use it and your house is freezing, but you have this awesome smart thermostat that you spent a lot of money on. Great. Ridiculous password requirements. Minimum 8 characters, maximum 10, 2 emoji and a Chinese character, please. Bad advice. I know this has been parroted by information security professionals all around the world for years. It is horrible advice. That's not how people work. We're going to get into that a bit later. And I don't know if you remember this, but the Equifax data breach. Millions of customers, credit card data leaked all around, servers weren't updated, software from 2005 running with massive security holes in it, and people are surprised that that breaks. But there is one common denominator between all of these, one group of people involved in all of these problems. And I'm not sure if you already have an idea who it is, but I'll give it away. It's us. For every one of these problems, at some point during the process, an engineer was involved, built something, made the decision to listen to their manager when the manager said, nah, we don't need to update this, it's fine. It's been running like this for 15 years. It'll hold for a few years more. There was an engineer who was asked to implement some ridiculous password policy and thought, you know what, I'll build it. All technical failures, well, I say all, I should probably say most, but as far as I have seen, pretty much all technical failures at some point involve engineers. Which is not to say the blame always falls on them, but they're always there, because somebody needs to do the technical thing, and that's usually an engineer. Don't let the marketing people do the technical things, it's bad. Look back on that Challenger disaster. What caused all that cascade of wrong decisions was basically a lack of feedback. It's called normalization of deviance. You have a range of safe operation, and that becomes the normal state. People start deviating from the normal state as they do, generally stretch the rules a bit, but then they find out that nothing catastrophic happens. So that deviation from the normal state becomes the new normal. People start deviating from that. And the reality is, nothing really goes wrong for a long, long time until it catastrophically fails. Like with the Challenger launch, your rocket blows up. Or take speed limits. That 100 km/h road, people start driving 110 and nothing bad happens. So that becomes normal, and people start to drive 120 and nothing bad happens, because, you know, the speedsters, they pay extra attention to police cars if nothing else. But then it rains, and that 120 km/h that was perfectly safe before is suddenly not safe anymore, and people crash. things catastrophically fail all at once when you start slowly introducing deviance from the normal state. Feedback can help that. If small bad things happen when people deviate from the normal state, people will stop deviating more from the normal state because bad things happen. We tried that with speeding tickets. That works to some degree. But in technology, we can actually mostly detect these deviances. We can, for instance, just make some component refuse to work outside a certain range. Not always a good idea. Watch out when you do this, because sometimes things just need to work outside their normal range of operation in order for things to not go catastrophically wrong. It's a slippery slope, but feedback can help. And you know, sometimes we can just give verbal feedback. I noticed you used it in that way. That's really not what it's intended to do. Things will fail. That's feedback. It doesn't always solve the problem, but it can help. Now I think we need to face reality a bit, and this might be the wrong audience to say this to, given who I'm talking to, but working with developers is kind of hard. We have to admit that. We work in an industry where the standard for social skills is ridiculously low. If we all put on pants in the morning, everybody's happy. If we manage to talk to people without making a complete ass of ourselves, everybody loses their minds. Like, oh my God, is this a developer? We never would have guessed. We're different. Honestly, we're not that different. We're just people. It's just that we don't hold ourselves to that good a standard, so we tend to be basically assholes to everyone we meet. We're a little difficult to work with. I'm sure some of you, most of you, have at some point heard, oh, those bloody IT people always saying no to everything. They speak this weird language, and you really can't communicate with them. I've heard it a lot. Thankfully, not about myself mostly, but I have heard it. And honestly, even for ourselves, we're hard to work with. We're a gatekeeping bunch. You're not a real developer unless you do backend. You're not a real developer unless you do an actual compiled language. Not that scripting bullshit that PHP is. You're not a real developer unless you use strict typing. You're not a real developer unless you use the newest version of everything. Why? What's the difference between all of these? Why do we need to push people away who are trying to learn things, who are trying to do things, trying to build things? They're essentially trying to do the same thing as we do, maybe in a different way. And of course you can be convinced that your way is better for some reason, but instead of pushing them away and calling them noobs or whatever term you'd like to call, maybe take them in, show them the error of their ways, if there is such a thing. You might actually learn that you're wrong. We also do this in code reviews. There is a way to go about code reviews, and bouncing things back with "this sucks, build it again" is not the way to go. That does not actually result in things getting better. That just results in people not asking you to do code reviews anymore. There's a lot of animosity going in there, and while it's not usually with those direct terms that it is being done, it does kind of come across that way sometimes. I have done, looking back at it now, I did it completely the wrong way. I've done a code review at some point for a password reset functionality. Now, password resets are quite tricky because you're essentially offering your users a way to completely bypass your authentication. That's tricky to do in a safe way. So, I'd read up on security, I'd read up on how to properly do it, I read up on pitfalls, but somebody else implemented it and offered it to me as a code review. Now, as is usually the case with complex features, during a code review, I noticed some problems. Timing attack here or there, a direct reference where there really shouldn't be one, nothing too enormous, but there were problems and they needed to be fixed. So I addressed these in a comment, explained what was wrong, bounced it back, and asked him to fix those problems. Problems got fixed, new problems got introduced, as is often the case. Merge request was reoffered for code review, and I did the exact same thing again. I explained what was wrong, told him what the solution would be, and I bounced it back. You need to fix it. This happened 4 times. That's a problem. Once is fine, but at the second time, I really should have paired up with him. I should have said, you know what? You're having some trouble with this, that's fine, it's tricky. I happen to know a thing or two about this. Let's just sit down together and build this the right way. Would have saved them a lot of frustration, would have gotten the feature completed probably a week earlier. And it would have, you know, in the end, that developer who offered me that merge request was really, really good at taking feedback. He did not take any of it personally. He got frustrated, but he really realized that this was feedback on his code, not on him. But not everybody's like that. Not everybody can take feedback that way, and doing things like that can really result in people feeling like they're not good enough or just plain hating you, honestly. But there's no reason to only do this with developers. Why not pair up with the designer once? If you pair up with a developer, you learn more about the way they do things, the way they see things, the way they implement their features, the way they think about their code. That helps you learn new things because you might come to new insights you didn't have before. It helps them learn new things because they learn a new way of looking at their code. So what do you think happens when you pair up with a designer? I mean, I don't know about you, but their craft, art, whatever you wish to call it, is a complete mystery to me. You toss colors and shapes at something and suddenly it becomes pretty. I've tried to do design, I absolutely suck at it. Don't ask me to design anything, you will end up with a horrid mess that is both ugly and unusable, which is a skill, I suppose. Just not the skill you tend to want. But if you pair up with a designer, you might learn something about their process of thought, about how and why they use these colors and shapes to have an effect on people, to cause them to click a button or to not click a button because they need to offer that option, but they don't really want people to use it. I'm looking at you, no, I do not accept all cookies. Same with marketing people. Sure, they come with outrageous claims and outrageous requests, but these don't come from nowhere. They don't just pop out of a void. I genuinely believe that most marketing people believe the bullshit they spout. When they say it's unhackable, blockchain encrypted, they actually believe that it is unhackable and blockchain encrypted. They need somebody to tell them that that's not the case. If you pair up, you can actually tell them that before they release the press statement, not after, which is too late because now it's already in the world and you're getting free penetration tests from people on Twitter. Pair up with people. You'll learn something new, and while you might not learn to do what they do, you'll learn the logic behind them. You'll also learn how they think and how to give them feedback. Because honestly, when a designer gives you a design for something, they could care less about how hard it is to implement. They really don't care. They want it to be implemented and want it to be implemented right. Once you learn the purpose behind their design, you can sit down with them. You can start talking about, hey, this is really hard to implement and we're probably not going to do what you want us to do, simply because that's just either technically impossible or it's going to take an exorbitant amount of time. But what we can do is something else that will hopefully achieve the same result. People are generally receptive to people trying to do that. They tend to like it when people listen to them and try to understand what it is they do. Same way we try and kind of enjoy it when a designer comes to us and tries to understand why it is that things are so technically challenging. The same goes for every discipline. Just talk to people. It helps. It's not us versus them. In the end, we're all trying to do the same thing. We're trying to build a product. We're trying to get people to use that product. We're trying to get people to like that product. Cooperation is key for that. We can't do that alone. You can't let developers do everything from design to implementation. That's how you get Bugzilla. Like literally, that is what it results in when developers do UX design. It is horrible. Sure, everything's in one place, but you can't find anything. Kind of like your desk once you've left it alone for a year. We all have our expertise. For us, that is mostly development, either implementing the business logic behind things or making things, translating that design to the right code that will make it look and work the way it's supposed to. Some people are really good at taking that product and convincing people that it is as awesome as you think it is. Others are really good at actually getting them to hand you money for it, which is harder than it might seem, even if you have an awesome project. Because people will agree that it's awesome, but they will be hesitant once you ask them for money. These are all expertises you need. You even need managers. Maybe not in that specific role, but you need people who enable people to do the work they have to do. If you take out managers or those who do those jobs from the entire equation, you end up with everybody doing that job and not doing the job they're supposed to do, because they have too much going on, like responding to emails from clients and making sure all the budgets are being met and making sure you have enough time to do everything, and then it turns out you have 3 hours left for actual development. So work with them. In the end, they all want something. They want to know something from you. They don't want to know everything from you. Honestly, your manager doesn't really care what refactorings you've done, what classes you've written, and how many lines of code are in that controller. But they do care about what you need, what you encounter. If you tell a manager a week in advance, hey, this is going to be more complex than we thought. I know I said 2 days, but it's probably going to be a week. They can act on that. If you tell them after 2 days it's not done, it's going to take another 5, they can't act on that anymore. Because it's too late. You've already invested time. If you told them in advance, they could say, well, we don't really have the time to invest a week in this. Let's do something else instead. If you tell a designer afterwards, hey, that design was super complex, it took a lot of time, it is bullshit, and it doesn't work, they can't do anything with that. You've already implemented design. It's too late for feedback. If you tell them beforehand, hey, what do you want to achieve? How can we help? They can work with that. Communicate, cooperate, learn to understand each other, learn to understand what the needs are of every expertise you work with, learn to communicate your needs to their expertise. Being able to make that translation is crucial in working within a multidisciplinary team. Now, I know that animosity and, quite frankly, elitism are rampant in developer communities, whether it is towards other developers or even more to other disciplines, but they destroy your efforts to make something work. They just lead to frustration and suboptimal solutions. Now I get it. We're not all social creatures. That's okay. You know, I've mentioned that the expectations of social skills are ridiculously low. And honestly, we kind of deserve the stereotypes every now and again, but we're not bad people. It is, in a way, true that a certain type of people is drawn to technology, because we like logic, we like things to make sense, we like things to react exactly as we expect them. I know. I am like that. I also used to be completely incapable of talking to strangers. And utterly incapable. I could talk about 2 topics, and that was it. It might come as no surprise to you that there has genuinely been a suspicion of autism, and I'm still not convinced that I don't fall somewhere on the spectrum, but, you know, that's fine. You don't have to be a social butterfly. If you have one person in your team who can make that translation to other disciplines, to other people, that is enough. Learn each other's strengths, learn each other's weaknesses. Social skills are as much an expertise as anything else. It's just not restricted to one discipline. And honestly, even if you're not a social butterfly, if you can talk to other people without being condescending, you're 80% of the way there. Just be respectful to people. And if you honestly don't know how to talk to people in other disciplines, this is something you can learn. Get one person on your team who can do that, watch them attend meetings, watch how they communicate, try to mimic that. You'll get there. I had to learn it too. Here I'm fairly good at it nowadays. Wouldn't know, but yeah. It is something you can learn. Social skills are called skills for a reason. They're not something you're born with, you learn them. But in the end, you can't make everybody happy. People can sometimes be difficult. Things can sometimes be impossible. If your manager really, really insists that week's worth of development has to be done in the next 2 hours, that can't be done. You can't just type faster and expect more good code to come out. If something comes out at all, it's probably going to be gibberish and it's going to do exactly nothing except break your entire application. Things can be impossible, and people sometimes can have trouble accepting that. And that's okay. You're not here to make friends, honestly. And I know that's a bit counter to what I've been saying for the past 30 minutes, give or take. But you're honestly not here to be friendly with everyone and get everybody to like you. Every time you've been frustrated with a marketeer or a salesperson or a manager because they've made some demand, is because they've realized that, you know, I'm not here to make friends, I'm here to get this work done. And this is how I think I'm going to get the work done. They might not always be right, but they are right that they're not there to make friends. The same goes for us. Sometimes we just have to say no. Nobody likes saying no, but it's worse to say yes and then not do anything. Better to underpromise and overdeliver, as people say. Now, don't take that to extremes, but it is good to err on the side of caution and say maybe and then do it, rather than say yes and then turn it out you can't quite make it. Now, if you remember my point about feedback, saying no is feedback. Just standing up to manager, salesperson, marketer, designer, you name it, even another developer, and saying no, I cannot or will not do this, that is feedback. Might not seem like it, but they can work with that. Especially if you do not just say no. If you just say no, I won't do this, that tends to breed animosity and tends to be hard for people to accept. If you explain why things cannot be done, especially if you then offer an alternative, people tend to be much more receptive for that. And it can actually lead to better results too. I once had a client who had a very complicated bulk upload functionality with titles and descriptions for photos and everything in mind. They wanted that implemented. It was so important to them that that was implemented, but it was so much work and there was never time to do it. Until we sat down with them. And it turns out that yes, they had thousands of photos that needed uploading, but they really only needed to upload them in bulk and add a description to maybe 1 or 2 of them. So this very complicated functionality that they had in mind, it was completely unnecessary. We ended up just using jQuery file upload for a bulk upload functionality and using a basic Sonata form just to give them the possibility of adding a title and a description for the 1 or 2 photos they wanted to. 2 days later, they had it on production. Everybody was happy. We didn't have to waste enormous amounts of time on some weird functionality that nobody was going to use. They didn't have to pay who knows how much money for something that was completely the wrong solution to the problem they actually had. Giving that feedback enabled us to do that. Sitting down with people enabled us to do that. And honestly, aside from maybe not having the right solution to things, sometimes the solutions that are offered are just plain bad. That password policy I showed you that was very long, that is a bad idea. We have a professional responsibility. When we choose to implement those things, we are partially responsible for the results of that implementation. When people's passwords get hacked because they have that ridiculous requirement and they turn out to just cycle 1 number at the end of them, they go from password 1 to password 2 all the way to password 15 and then their account gets compromised. That's on us. Because we know this is a bad idea, but we do it anyway. We have the responsibility to say no to that. Now, it might not always work out. Sometimes you just have to do things. But remember that. Remember that you have the responsibility to, at the very least, say no to that and try to get people to see reason. Try to explain to people why that's a bad idea and what's a better idea, namely minimum of 8 characters and check if it's not compromised somewhere else. It's the best password policy you can have. Say no to bad ideas, seriously. Now, I noticed I'm going a bit faster than I intended, but I think that's okay. Better to end a bit early than a bit later, but I want to, if there's one point I want you all to carry away from this talk, it's this. You might recognize this line from somewhere. for those of you who don't, it is, I think, the first line in the Agile Manifesto. Individuals and interactions over processes and tools. And it is amazing to me that when it comes to software development, just the actual building of, writing of code, the building of something technical, we accept this as absolute truth. Sorry. We see this as the evangelism to preach to everyone. We have to value people, we have to see how people work together, and then we have to focus on processes and tools. But once it goes outside the technical spheres, we start to force our processes and tools on everyone so we control how we interact with people. That's the wrong way to go about things. Why not just work with people? The processes and tools will come. People interact with your software. And honestly, they make the best of ideas bad. I've seen people complain about, oh, I've made this super intuitive UI, but the users can't figure out how to use it. Well, guess what? That means your UI is not as intuitive as you thought. What defines an intuitive UI is how your users want to use it. The same goes for technical solutions. Oh, this is a great, elegant solution. We have a perfect way of doing this, but it doesn't work with the front end. Well, guess what? It's not as perfect as you thought it was. You've solved the wrong problem. Work with people. Figure out how to interact with them. Then let loose your processes. Then start using tools. It's also that's also the case in security, mostly. If you recall that password policy, the reason that was parroted is because we start introducing processes and tools to force people's interactions. We start giving this list of requirements. This is what makes a safe password. And if you are a machine, then yes, that absolutely makes a safe password. But at the end of that list of requirements is, don't write it down and don't make it easily guessable. Those things are not enforceable by technology. So people circumvent your tools and your processes and start doing dumb stuff. Like password 15. And oh, I need to change it again. It's going to be password 16 this time. If you flip that around, which information security professionals have realized in recent years, embarrassingly recent years, I might add, you figure out that people work that way. You figure out that letting them free actually has better results. But there are certain things you need to work out, certain things that people cannot work out for themselves. Namely, is this password already on a list somewhere? Because let's be honest, nobody does brute force attacks anymore. You just have a list of known passwords and you let that loose on an authentication form. So what you have to do is you have to realize we let people free to pick whatever password they want, because it's going to be easy for them to remember, as it should be, or even better, it's going to be in a password manager and nobody's going to have to remember anything. But it cannot yet be compromised. You catch 99% of all problems with authentication that way. And if you then stimulate two-factor authentication, brilliant. Even in that 1% of cases, nothing's really lost. People got past one layer of authentication and then you can just ask people to change their password. People first, then processes, then let loose your technology on them. Learn how people work, write your processes around that, your set of rules, your ways of interacting, your regularly scheduled meetings, then see how your tools can help that, not the other way around. The most important thing you should take away here.